Hello everyone, welcome to Mastermind. Let us learn about neutrinos in this video. Neutrinos was proposed by Wolfgang Pauli in the year 1930. It was first proposed by Wolfgang Pauli in the year 1930, but it took another 26 years, that is in the year 1956, Reines and Cowan found evidences of neutrino. Reines and Cowan Reines and Cowan found the evidence of neutrino interactions by monitoring a volume of cadmium chloride. Please remember this, cadmium chloride with scintillating liquid near to a nuclear reactor. So, the evidence of neutrino was found by Reines and Cowan in the year 1956 while monitoring a volume of cadmium chloride with scintillating liquid near to a nuclear reactor. Reines was actually awarded with the Nobel Prize in the year 1995 for this work. It was a revolutionary work because detection of neutrinos paved a new way in the physics research. Now let us see what are neutrinos. Neutrinos are fundamental particles. Neutrinos are fundamental particles belonging to lepton family. Please remember, they belong to lepton family. This is very important. They could ask you this question in multiple choice. So please remember, it belongs to lepton family. Neutrinos actually come in three flavors. Neutrinos come in three flavors. The one is associated with electron, the other is associated with muon, and the final one is associated with tau. So what are these neutrinos called as? The one associated with electron is called as electron neutrino and is denoted by the symbol as shown here, VE. Next, muon neutrino is denoted by the symbol V mu. Tau, tau neutrino is denoted by the symbol Vt. These neutrinos are chargeless. Please remember, they do not carry any charge. According to the standard model of particle physics, they were considered to be massless. However, recent experiments have indicated that neutrinos have finite but small mass. They oscillate between various flavors as they propagate. So neutrinos are tiny neutral elementary particles which interact with matter with weak force. The weakness of this force gives neutrinos the property that matter is almost transparent to them. Neutrinos are almost transparent to the matter. You have to understand that millions of neutrinos stream through us every day. They pass through our body every day because these neutrinos are tiny neutral elemental particles. They do not carry any charge. That's why they are called neutral particles, and they are fundamental particles in the sense that they build atoms, they build the matter. So neutrinos are tiny neutral elementary particles which interact with matter via weak force, and since they interact with the matter with weak force, they are almost transparent to the matter. Now let us look at the sources of neutrinos. Neutrinos are sourced from Sun, stars and other cosmic bodies. Sun and all other stars produce neutrinos copiously due to the reaction called as nuclear fusion. The Sun and all other stars produce neutrinos copiously due to nuclear fusion and decay processes within the core of the Sun, within the core of the stars and the other cosmic bodies. Neutrinos are produced. Since they rarely interact with the matter, I have already told you that neutrinos interact with very weak force, and since they rarely interact, as they interact with the weak forces, these neutrinos pass through Sun and Earth unhindered. They pass through Sun and the Earth unhindered. Apart from Sun and stars, there are also other sources of neutrinos such as supernovae. Supernovae are nothing but exploding stars. Supernovae, which is nothing but exploding stars. When stars explode, they give rise to billions of neutrinos. Along with this, there are relic neutrinos. Relic neutrinos are from the birth of the universe. When the universe took birth after the Big Bang theory, when the universe took birth after the Big Bang theory, neutrinos were born, and these neutrinos were called as relic neutrinos. Apart from this, radioactivity, natural radioactivity also gives rise to neutrinos. Along with this, cosmic ray interactions. Cosmic ray interactions in the atmosphere of the Earth also gives rise to neutrinos. For example, Sun produces over 200 trillion neutrinos every second. Sun produces trillions of neutrinos every second. But a supernova blast, that is the explosion of a star, can unleash 1,000 times more neutrinos. 1,000 times more neutrinos than our sun will produce in 10 billion year lifetime. So many neutrinos could be produced in a single supernova. Billions of neutrinos stream through our body every second. Billions of neutrinos pass through our body every second. However, in our entire lifetime, we can interact only with one or two higher energy neutrinos. There will be exceptions. One or two high energy neutrinos will interact with us in our entire lifetime. Other than that, billions of neutrinos pass through our body, goes unnoticed because they interact with a very weak force with the matter. However, there will be one or two neutrinos, high energy neutrinos, that get noticed or we will get to interact with in our entire lifetime. Now, let us look at the importance of the neutrinos. Why should we detect the neutrinos? What are its features? Neutrinos hold the key to several important and fundamental questions. They key answers to many fundamental questions in the universe. The questions might range from origin of the universe and energy production in stars. So we only have some partial answers regarding these things, but many details are still awaited from future experiments that involve neutrinos. So neutrinos hold the key to several important and fundamental questions on the origin of the universe and the energy production in stars. So neutrinos are vital to find answers to some of the fundamental questions regarding the universe. Another major application of neutrinos is in the area of neutrino tomograph. Please remember, neutrino tomograph of the Earth. What is the neutrino tomograph of the Earth? We have already seen that neutrinos rarely interact or rarely get noticed because they interact with weak force. So the neutrino tomograph of the Earth gives us the detailed investigation of the structure of the Earth. It gives detailed investigation of the structure of the Earth from core onwards. This is possible with neutrinos since they are the only particles. Please remember, neutrinos are the only particles which can probe the deep interiors of the Earth. They can pass through deep interiors of the Earth as they are transparent to the matter, as we have already seen. They travel to the deep interiors of the Earth as they are transparent to the matter, and the detection of these particles in the deep interiors of the Earth can provide us detailed investigation report of the structure of the Earth from core onwards. In addition to these, there are other recent astrophysical measurements that provide information on the evolution of the universe. There are also parallel astrophysical measurements. There are other research experiments that are going on. So these astrophysical measurements that provide information on the evolution of the universe can extract lot of information from the neutrinos. It is crucial to seek complementary information by direct determinations of the masses of neutrinos and their properties. So if these astrophysical measurements are complemented with the findings of the neutrinos, their masses and other properties, we can get a detailed report of various investigation with respect to universe, its origin and evolution. So this is all about neutrinos in this video. Please go through the video multiple times and also refer to the articles as well. This is a very important science topic. Thank you.